So dear students, welcome back, and the topic is again area of a surface of revolution. In part 2 of this lecture we want to solve 8 problems. Problems 1 to 4 is related to our formula 1 and problems 5 to 8 is related to our formula 2. Formula 2 I mean about y-axis integrating with respect to y, and formula 1 I mean about x-axis, it means integrating with respect to x. So let us try to calculate area of the surface that is generated by revolving this curve from 0 to 1, and you need to revolve about x-axis. So in this case, for formula 1 to 4 we are going to use this formula. Area of surface of revolution is equal x equal a to x equal b 2 pi y 1 plus dy dx whole square root dx. So here we are given y equal to 7x and the derivative of this one is 7. So this integral becomes 0 to 1, since x lies from 0 to 1, 2 pi y is nothing but 7x. The square root of 1 plus dy dx is 7. So 7 square dx, and this equal, I can take this out of this integration. So 14 pi 0 to 1 x root 50 dx, which is equal 14 root 50 pi 0 to 1 x dx, and this equal 14 root 50. Root 50 is equal to root 2 times 25 root, so I can take this 25 out of this square root. It will be 5 root 2. So let me write here 5 root 2 pi, and integration of x square by 2 0 to 1. This equal 14 into 5 root 2 into pi into 1 half. If you put the upper limit, I will get 1 minus 0 for the lower limit. So this equal, I can simplify it, 35 root 2 pi. So this is the answer. Now let us try second one. Here y equal root x. Y equal root x. So dy dx will be 1 by 2 root x. So the formula is the previous one, since we are revolving about x-axis. So x is from 1 to 4. I can write here 1 to 4. 2 pi y equal root x, square root of 1 plus 1 by 2 root x whole square dx. So this equal 2 pi, let me write out of integration, 1 to 4 root x square root of 1 plus 1 by 4x dx. This equal 2 pi 1 to 4 square root divided by 2 root x, because the numerator, if you simplify it, the numerator will be 1 plus 4x and denominator will be root 4x, and root 4x is this dx. You can cancel this and this, so you have 5 1 to 4 1 plus 4x square root dx, and let us substitute 1 plus 4x by z. So dx will be dz by 4, and the corresponding value of z will be 5 and 17. So this integral becomes 5 to 17 root z dz by 4, which is equal 5 by 4, z to the power 3 by 2, 2 by 3, 5 to 17, which is equal 5 by 6, 17 root 17, if you put the upper limit, minus 5 root 5 if you put the lower limit, and you can approximate it by using your calculator. That will be 30.85. So this is the area of the surface of revolution if you revolve the portion of this curve about x-axis. Now let us try third one. Third one is a bit important for several exams. So here y equal root 4 minus x square, and the limits of integration will be minus 1 to 1 2 pi. Let me write y, which is 4 minus x square root 1 plus dy dx will be 1 by 2 root 4 minus x square. And we need to use chain rule. The derivative of 4 minus x square is minus 2x. Minus 2x. Derivative of 4 minus x square minus 2x, which is equal minus x divided by, you can cancel 2 and 2, root 4 minus x square. And the square dy dx, if you square it, you will get x by 4 minus x square. X square by 4 minus x square. So let me write it here. The square of the first derivative is x square by 4 minus x square dx. So let me simplify it, and 2 pi we can write out of integration, and we have 4 minus x square times, if you simplify it you will get, and denominator I will get root 4 minus x square, and in the numerator I will get 4 minus x square plus x square dx. So I can cancel this one and this one, and I also can cancel x square and x square. So I have 2 pi minus 1 to 1 root 4 dx, and root 4 equal to 2. So I can also take this one out of integration. I have 4 pi minus 1 to 1 dx, which is equal 4 pi integration of 1 x minus 1 to 1. This equal 4 pi. If I put the upper limit, I will get 1 minus lower limit. So 4 pi times 2, which is equal 8 pi. So 8 pi is the answer. So now let us try to solve problem 4. Here our given curve x equal y to the power 1/3, and I need to write y in terms of x in order to use formula 1. So from here I will get x to the power 3, and dy dx will be 3x square. So let me put it here, and the values you are given for y, but you need to convert it to x. So how can we do that? When y equal to 1, x equal what? X equal to 1. So the range for x will be when y equal to 8, and 8 to the power 1/3 will be 2 cube, all to the power 1/3 will be 2. So the range of y, this range will convert it to 1 to 2 for x. So my lower limit will be 1 and upper limit will be 2, and 2 by y equal x cubed. So x cubed root 1 plus dy dx, 3x square whole square dx, this equal to pi 1 to 2 x cube square root of 1 plus 9x to the power 4 dx. Now let us do the substitution. 1 plus 9x to the power 4 equal to z. So 36x cube equal dz and dx. So x cube dx equal dz by 36. So the corresponding value of z will be, when x equal to 1, if I put here, z will be 10, and when x equal to 2, 2 to the power 4 means 16 times 9 equal 144 plus 1, so 145. So this integral becomes 2 pi 10 to 145 root z dz by 36, which is equal pi by 18. If I can cancel 2 and 36, I will get 18. And integration of root z to the power 3 by 2, and 2 by 3 I can write here, 145, and 10 is the lower limit. So equal, this equal pi by 27, and if I put the upper limit, I will get 145 root 145 minus 10 root 10. But I can also take 5 from here and here, then it will be 5 pi by 27, and here I will get 225 root 145, should be 29, minus 2 root 10. So this is the answer. So now let us try to understand problem 5 to 8, and for these curves we are going to revolve our curve about y-axis. So the area formula will be surface area generated by this portion of the curves will be integration from y equal to c to y equal to d twice by x 1 plus dx dy whole square root dy. Okay, so for the problem 5 we are given x equal 9y plus 1, and the limits of this curve is from 0 to 2 pi, and x equal 9y plus 1 square root of 1 plus dx dy is here, which is equal to 9 square dy. So this equal 0 to 2 9y plus 1 square root of 82 dy. So I can also take this one out of integration, 2 root 82 pi, and integration of 9y square equal 9y equal 9y square by 2 and integration of 1 equal y. This is our limit 0 to 2, which is equal to root 82 into pi. If we put the upper limit, it will be 4 nines into 9, so 36 by 2 plus 2 minus 0. So the final answer will be 40 to 40 pi root 82. This is the answer. And for the next problem, problem 6, here x equal y cube. So dx dy is equal 3y square, and our area formula is equal the lower limit 0, upper limit 1, 0 to 1 twice pi x equal y cube square root of 1 plus dx dy whole square. So 3y square whole square dy. This equal 2 pi 0 to 1 y cube root 1 plus 9y to the power 4 dy. So we can do the z substitution as before, which is equal z, and 36y cube dx equal dz, therefore y cube dx equal dz by 36, and the corresponding value of z will be when y equal 0, z equal 1, when y equal 1, z will be 10. So this integral becomes 2 pi 1 to 10 and y cube dy, which is equal dz by 36 root z, and this equal pi by 18, z to the power 3 by 2, 2 by 3 is here, 1 to 10. So this equal pi by 27, 10 root 10 minus 1. This is the result. So now let us try example 7. Here we are given x equal root 9 minus y square, and the limit of integration is from minus 2 to 2. So let me write it here, minus 2 to 2, 2 by x equal root 9 minus y square times, let me do it here, dx dy is equal 1 by 2 root 9 minus y square into chain rule, derivative of this minus 2y, which is equal minus 2 and 2 you can cancel, minus y by root 9 minus y square. So let me square it here, dy by dx whole square equal y square by 9 minus y square. So it will be 1 plus y square by 9 minus y square dy, which is equal to pi minus 2 to 2 root 9 minus y square, and here if we simplify it, the numerator will be root 9 minus y square plus y square, and denominator will be 9 minus y square. So we can cancel this term and this term. I only have minus 2 to 2, we can also cancel this one. So root 9 dy, and root 9 equal to 3, so it will be 6 pi integration from negative 2 to 2 dy, which is equal 6 pi integration of 1 equal to y minus 2 to 2. So this equals 6 pi 2 minus minus 2, which is equal 6 pi 2 plus 2, it means 4. This equal 24 pi. So 24 pi is the answer. So now let us try our last example in this lecture 8. And here we are given x equal 2 root 1 minus y. So dx by dy will be 2 into 1 by 2 root 1 minus y, and the chain rule, derivative of 1 minus y equal minus 1, and 2 and 2 you can cancel. So the derivative will be minus 1 by root 1 minus y, and the square of this derivative will be 1 by 1 minus y. So let me put this result here. The lower limit of this integral will be minus 1 and upper limit 0. So minus 1 to 0, 2 pi, and x equal 2 root 1 minus y, square root of 1 plus dx dy whole square, which is 1 by 1 minus y dy. And this equal, we can take this 4 pi out of integration. 4 pi minus 1 to 0, square root of 1 minus y, and square root of the denominator will be root 1 minus y, and the numerator will be 1 minus y plus 1 dy. So we can cancel this one and this one, which is equal 4 pi minus 1 to 0 integration of 2 minus y dy. Now let us integrate it, which is 4 pi 2 minus y whole to the power half plus 1 divided by half plus 1 into derivative of 2 minus y, which is minus 1 to 0, this equal. So here you have 4 pi into negative 2 by 3, because the lower limit is negative 3 by 2. So if you take it in the numerator, it will be negative 2 by 3, and 2 minus y to the power 3 by 2, and the limits, lower limit minus 1, upper limit 0. So we have here, we have minus 8 pi by 3, and here if we put the upper limit, we have 2 to the power 3 by 2, and if we put the lower limit 2 minus minus 1, then it will be 3 to the power 3 by 2. That will be 8 pi by 3, 3 root 3. This term we want to take it, we want to write first, because I want to remove this sign, minus sign here. So 3 root 3 minus 2 root 2. This is the answer. So that's all in this lesson, and hope you enjoy the class, and hope to see you in the next one. Thank you very much.